Okay, today I will introduce the basic of pandas. Since some of you may be familiar with the pandas module, so I will introduce the basic concept skill very fast. So the panda, okay, comes from Python and data analysis or panel data. Okay, uh, it is a Python package. Okay, and contains the function of NumPy and SciPy or Matplotlib library. Okay, the purpose of a Panda is to help the programmer uh, to process the data or analyze the data. The basic object or structure of Panda are series, data frame, and panel. Series is for one dimension array, and data frame is basically is for two dimension. Although it can support multi-dimension, but in most cases we will use it for two-dimension data processing. And panel, we although it is defined in pandas, but we seldom use panel to process the data. So in order to use pandas, first you need to install the pandas. Okay. Then in your program, you need to import the panda module. So usually we use PD as the abbreviation of pandas. And these are the basic types in pandas. First one is float, okay, then integer, then integer with 64 bytes to represent the integer. Another is the object. Okay, object is used to store string or mixed type data. So suppose that, for example, that the data contains the numerical value and the string value. So we use the object. And category is used for data classification. So you maybe classify the data maybe into different class. So like gender, blood type, and so on. So it is called a category. And type is Boolean. Okay. And datetime format. Okay. In pandas, we support datetime data. Also, it is datetime 64 bytes. Okay. And okay, the missing value for the datetime is the NAT, means not the time. Also, you may you may see the data like NaN. It means that the value is not a number. Okay, so yeah, not a number. Okay, these are the special value that you should know. Okay, first we'll talk about the series. Okay, series is like NumPy's ND array to store one-dimension data. Okay, But although it is one-dimension data, you can view the series that contains two arrays. One is the data, the other is the index for the data. Okay. So in series, data can be integers, floats, and strings or objects. Okay. Basically, the index is the range index object. So the range index object, like range in Python, right? So range index is all can be described by start and end and the step. Okay. These three values. And the range index, you can uh, think of it as a special index that use in series or data frame. So this is the very basic, simple case for series. So like this, we just put the data into the constructor of series. Okay. So if you print out the series, then you will see. Okay. This is the value. This is the value of the series. And this is the index for the series. And because we do not assign index for this series, so the series is auto-generated by the system. You see the index start from 0 and go to 5. And the step is 1. Okay. So this is auto-generated because we do not specify the index value. Okay. And in this case, we construct the series and specify the index for the series. So we have fruit, the value, quantities. Okay. And we use fruit as the index. So if you print out the index, if you print out the series, then you will see the series. Okay, series data. And these fruits, okay, these fruits are indexed for the series. And for index, there are some useful property. So suppose that the index property, you will get the index for the series values, and you will get the values of the series. Okay, so because the index is fruit, so you see this is the index of fruit, and this is the value for the series. And we can construct a series using a dictionary. So you see here, we construct a series with a dictionary. And the key of the dictionary will become the index of the series. So if you print out, then you will see, okay, 2, 1, 3 are the keys. They become the index of the series. Also, you can express, you can use like that. Okay. Then you see that suppose the 2, 1, 3 should be indexed, and the value should be A, B, C for the series. But you see, we limit, you can think as limit. We set the index only contains 3 and 2. So the series, the 2 and 3 element, 2 and 3 index element becomes legal. But for the index 1, because we do not assign in the 1 become the index of a series, so this data becomes invalid. So if you print out the series, you will see that 3 and 2 become the index of the series, but not including 1. And another important concept that we can view a series as a special dictionary. So this is the dictionary, and we can construct a series from the dictionary like this. So in this case, the key of the dictionary becomes the index of the series. So you print out the population, then you will see these the keys of the dictionary become the index of the series. Okay. Then we can access the element of a series using some indexing method like a list. Okay, so we can use population California, then we will get the value. Okay, so you see here we can get a value. So I run it again. Okay, you see here, right? You access the element by California, and you get the value of corresponding to the California. Okay, this is the how we make a series from a dictionary. And these are the functions or property for the series. Okay. So this is the property. NDIM means the dimension. Okay. And here is the shape of the series. Okay. And because the series is one dimension, so maybe the shape will like that, only one dimension. Okay. Size means the number of elements of the series. This is the data type. Okay, the data type of the series, and this is the data types. Okay, suppose that you have more than one data type for the value, then you will data types, and these will get the values of the series, and this will get the index of the series. Okay. So then this is easy now. S0 is the series, and you will print out the dimension. Then you will get this because it's only one dimension. And shape, okay, only you have three elements in a series, so you just have three. Size, number of elements, 3. Okay. Data types, okay, because these values are all float numbers, so this will be float. And this we build another series, and you want to get the data type of the series, and because the element, the value of the series you see here, including the integers and the string, so it is a mixed type. It is a mixed type object, so the type will be object. Values, okay, S0 value, so these are the value for the S0, and the index, okay. And because we do not assign index for S0, right? So actually the index of S0 is auto-generated by the system. So you see here that we have 3 elements in S0. So if you get the index, you want to get the index, it will return range index object, okay? And this is the range starting from 0 and ends at 3. You can think of 3 minus 1 like a range. So you can think that it will include three integers, 0, 1, 2, okay? And we step is 1. So you will generate 0, 1, 2, 3 numbers, 3 integers. And here is the example to get part of the series. So we can get the part of the series by some skills like slicing in list. So you see here, we can use same expression as list to get the value of the series. So it will get the first, because the index is 0, so we will get the first element of S0. So we will get 4.3. And this we will get the elements whose index starts from 1 and to the last element. So this is the index 1 element, and we will get the 2 elements here. Okay, and this is another special representation of the series. It means that if we want to get multiple value of the series, so we just want to get the element, okay, whose index is 0 and 2. So you see the result here. Okay. So if you want to get the multiple elements, so you need two symbol here. Okay. And we can assign a new value also. So here we assign a new element whose index is 4 and the value is 7. So you now because the originally S0 has 3 elements, but now we added 1 element into the S0 series. So you see, if you print out, you will get the 4 elements. Okay, and this we change. Okay, we try to we first search if there is any element whose index is candy. But you see here, the S0 series has four elements here. So now, and there is no element whose index is candy. So it means that we add it or insert a new element into S0 series. So if you execute it, you will print out, then you will have five element now. Okay, 0 index by 0, 1, 2, 4, and the candy. And there's a value for the candy index is 12. Okay. Okay, note that index can be different type. Like this example, the first 4 index are integers, and the last index is the string. Okay. And this is the S1 series. Okay. Indexed by ABC. And we can use here in A in S1. It means that we check if the A is the index of S1 index. Okay. And the 0 in S1. Okay. And because the S1 series, when you create the S1 series, it means that the ABC and the 4, 7, 8. Okay. These are the values for the series. Okay. And you check if the 0 is the index of S1. So you check here and you find no, the index is ABC. So 0 is not the index of S1. So it will print out false. Okay. Next is some useful related function of series. First is where. So suppose you have a condition and you want to replace some values if the condition is false, then you can use where function. And second is that you can replace the value with some value generated by a function. So that's more elastic. And the next is NA. So it's used to detect if there's any missing value in the series. So you will return Boolean series that indicate for each value if the value is missing or not. And another is not NA is for detecting existing value. You can think it's just the inverse of its NA. And fill NA is that you want to fill NA value with some value. So it is a very useful method. And in the method parameter here, you can specify how to fill the value. For example, you can fill the missing value with some value before the missing value, or fill the value with some value after the missing value. So it's very useful. And drop NA is that if you want to delete the NA values. So drop NA will return a new series with deleting the missing value. Append it is used in the older version of Pandas. In newer version, now is we use the concat function instead of using append. Okay, append is that if you want to insert some new values into the series, you can use append. But now we use concat. So next we'll see some example. So if S1 is the value, it's the series. Okay, here. So if you print out the S1, it will be like that. ABC 478. Okay. Then next is that you want to replace the value indexed by B to be -5. So you here you want to modify the value into to be -5. Then we see how where is used, and we have a condition here. Okay, before where we introduced that if you want to replace some value of the series, and you have a condition, okay, to test. Okay, so the condition now for this is as for the value greater than 0. Okay, so this is the series, and you test for the elements in the series to see if they are greater than 0. So the condition test, this will be true, and this will be false, and this will be true. and where we'll replace the value when the condition is false. So so this will replace the element, okay, with new value, and the remaining element will remain the same value. But in this situation, we did not assign the replaced value. We just set the testing condition. So Python will fill the value with NaN, means the value of this element is not a number. And the others, because the condition test is true, the result of a condition test is true, so their values will remain the same. So if you print out, you will see that the value of A is still 4, and the C value is still 8, but the value of B will be NaN. Okay. And the next instruction is similar to the previous instruction, except now we assign the value for the replacement to be 0 here. So now the value for the index B now will be replaced by 0 instead of NaN. And this is another example for is NA and not NA. For is NA, we see that is for testing the series if the values is NA or not NA. Okay. So okay, here, because S3 here. Okay, so if print S3, S3 will be like that. Contains 3 elements indexed by tea, cola, or coffee. And the value for cola will be NaN. Okay, so now if we execute its NA method, then it will test the value of S3. So for each value, it will test if it is NA or NaN. And for the T, because it is 33, it's 30. The value of 40 is 30, so it's not NA. So the result is false. For cola, because the value is NaN here, so the test will be true. And for coffee, because its value is 50, so the test will be false. So this is the result. It will return a Boolean series indicating if the value of the series is NA or NaN. And not NA is just the reverse of its NA. It just tests if the value is not NA or NaN. So and because S3, the value of S3 is here, and we test if the values are not NA. For T, okay, for T, the value of for T is 30, so the result of test is true. And for cola, because the value for cola is NaN, so the test, it is a missing value, so the test will be false. And for coffee, the value for coffee is 50, so the test will be true. So this is the result of not NA method. And this will be an example of a fill NA and drop NA. Okay. So first is the SR is the series. Okay. So we have these values, and we set the index for the series. So then we use field NA here. Okay. So it will fill the NA value with these values. Okay. So first we will see before the fill NA is executed. Okay. So before the fill NA method is executed, the the series the SR series is like that, and you can see that the value for CT4 is none. Okay, so here is none, or the value for CT4 is none, and the other element has values. Okay, now we execute this fill NA method. So it will test if the value of the element is NA or NaN. Okay, and if we test that, you can see because except CT4 element, the others are not Na or NaN. So it will replace the CT4 with the new values. But what's the new value for CT4 here? Okay, here. Okay, we just fill the new value CT4 with Lisbon. So if we execute the instruction, you will see that the value for CT4 will be Lisbon, and the other elements will remain the same. Okay, we just execute, and we will print out. You can see that all other elements, the value for other elements are the same. Okay, and the value for CT4 is now Lisbon. Okay, then we see the next. This is the new value for SR. Okay, now it's a new series for SR. You can see a lot of NaN in the series. Okay, and this is the index. Okay, here we use a special function called the date range. Date range will generate daytime data in a range. So you can specify the start, end, and interval, and or call step for the day or time. So in like this, in this example, we set this is the start, I think. Okay, this is the start. So the date start at 2010 and October 9, and there is the periods and the frequency. So frequency means that the generating of data or time is a monthly base. So in every month, it will generate one data like that. And periods is that you generate for 11 data, 11 day or 11 time data. Okay, so like this. Okay, also frequency equals to n means that you will generate the last day of that month. So although the day start at October 9, but you will generate the the date at October 31 because October 31 is the last day of October. Okay, so you see here, if you print out the index, you will see that first data is October 31, and then second data will be the end of the last day of the November. Okay, so you will see that the second data will be 11 and 30, and the third day will be the next month, so it's the December, and will be the last day of the December. So you will generate December 31. So like this, you will generate 11 data. Okay, so it's the index, and we set the index to be the series, to be the series index. So if you run this, you can see that now the index is replaced by the date generated by this. Okay, so here. Okay, so this is the last. If you print out, okay. So now we have two instructions. The first that is the fill NA. So you will fill the NA with the new value. Okay, and the method, the filling method is that ffill. Okay, so you need to know what does the method ffill means. Okay, so you can check here. So ffill means that you will fill the NA value with the value of last value observation forward to the next. So it means that the NA value will be replaced by the last valid data. That means that the data is not valid. Okay, so you see here is the NaN, right? The second and third here are the NaN, and here is NaN, and the last is the NaN. So we fill the NA value with the last data that is valid. So for this, suppose for this element, okay, the last valid data for the series is 100. So for this NaN value, this value will be replaced by 100. And also for this value, for the third value, the value will be replaced by, because the second value now is replaced by 100. So it is not NA, it is a valid value. So now the third value will also be replaced by 100. Okay. And for this NaN value, because the last valid value is 64 and 65, Okay, so for this NaN value will replace by 65, and for the last element of the series. Okay, so likewise, the value will be replaced by the last valid value, which is 24. Okay, so if you print out, so you see here, the second and third element of the value now is 100, and here, yeah, here, for this value before it is NA not available, now is 65. For the last value, for last element, now the value becomes 24. Okay. Okay, the last one is the drop NA. So this will delete NA value. Okay. So here SR. Okay. This is the this is the SR value, the S series, and because it will delete the element with the NA value, so like this, and this. Okay, these three elements will be deleted, and there will be 1, 2, 3. Because before there is 11 data, and if you delete 3, then we will be 8 data remaining in the series. So we executed the instruction. No, here NA, drop NA. Okay, here. So if we run the program, no. No, here. Oh, actually, sorry, there will be 4 NaN value in the series. So if you delete the values, the NaN values, then there will be 7 data remaining. So if you print out here, so you see here, only 7 data is remaining, and like this. Okay, this data is deleted, and this, okay, you can see that the data is deleted, and these two data is deleted in the series. Okay, so this is the drop NA method. Okay, the details you can see the description in the document. Okay, like in place. Okay, in place means that you want to replace the result. You want to replace with the new result. So the original data will be replaced with the new result. If we set it to be false, then usually you will create a new object storing or containing the new result. And another important options are the method. Yeah, and this option will be repeatedly used in the following functions. So there are a lot of like delete, insert, or replace method. So I suggest that you can see the options for the method in detail. Okay, and the other may be the access. Okay, uh, actually access is useless in the series because the series has only one dimension, so there's only one axis. So the axis options in the series is useless because it can be only one value. Okay, but later for in data frame, because data frame is can contains is two-dimension data. So there are two axis value in a data frame. So then there will be different. Okay, so suppose you want to uh, apply some operation on some axis, like maybe a row axis or column axis. So then the this parameter or this option is uh, is important. Okay, so but in series this option is useless. Okay, and maybe yeah. Okay, then these are some important options you may need to know in detail. Okay, and uh this is the example we usually use on a series. So suppose that we have S and P two series. Okay, and if we want to add or union these two series, and we can use a plus symbol. So like this, because the index for these two series are fruits. Okay, so the index are the same, and we want to add. Okay, add them together. Okay, and because s the value for s is the quantity, and values for p is the list. So this is the quantity. So if we add them together, then the value will be added. So you see that the value for the apple is 15 plus 11, so it's 23, and the value for tangerine is that 33 plus 16, so it's 49. Okay, so this is the union or plus. Okay, and we can also apply the sum function. So the sum function will add all the values and show the results. Okay, so this is the sum function, and we can like this we can do some simple calculation on this series, so no problem. And even we can apply some function on the series. So in this case, we apply sign function on the values of the series. So you see, for different index, for different element, we have different values. So this is a useful function, apply. Means that we can apply some function on the series. The next related function are duplicate and drop duplicate. So when a series has a duplicate value, we need to handle the duplicate values. So first that is the duplicate. It indicate the duplicate values, and they mark the these duplicative value in the series, and keep because the values are duplicate. So keep means uh, which value will be indicate. If the keep is first, that means we mark the first duplicate value as true, and last means we mask the last duplicate value as true. False means we mark all the duplicate value as true. So duplicate just mark the duplicate value, and drop duplicates will drop these duplicate values, and it will return the series after the duplicate value are removed. And some parameter like in place. In place is Boolean parameters. Okay, if this parameter is set to be true, then he will performs the drop duplicate function in the original series. So he will return. He will not return the result. He just do the drop or delete operation in the original series. So here's the example. This animals is the series, okay, and we can see llama is duplicate values. So we first just call the duplicate, and he will mark the duplicate value, and because he has no parameters, so here we see that here keep the default value for keep is first. That means we will mark the first duplicate value. So here llama is a duplicate value, and you see here we mark with this is the first llama, and we mark it false, and the rest of the duplicate llama are marked as true. Yeah, why the first one is marked false? Because later we may delete these duplicate values. So we just keep the first. We just want to keep the first duplicate value, and the rest the duplicate value should be removed. So we mark the the first duplicate value as false, so that if we delete according to the uh, result Boolean series, then the first value, the first duplicate value will be kept, can be kept, and the others will be removed. So here we mark the first duplicate value as false, and the others, because like cow or beetles, because they are not duplicate value, so the result is the results are false. Okay, and this is the result that if we set the keep uh, option as last, so we just mark the last duplicate value as false, and the others are marked as true. So the last llama is here. Okay, we mark it false, and the rest of llama are marked as true. And the cow and beetles are not duplicate values, so they are false. Okay, so set keep to false, and will mark all duplicate value. So here are duplicate llama, we mark it all true. And here we have a new series called S. Okay, and then we have llama, cow. Okay, more animals. Here we call drop duplicates. So, but without setting any parameters. So keep. Okay, keep is still default first. Okay, in place is false by default. So it means that if you call drop duplicate without setting any parameters, then they will not delete the value in the original series. They will generate a new object or result. Okay, and the original series will still be the same. So here we just call the drop duplicate, and you see here it will return. Okay, the function will return the result after removing the duplicate. So because llama are duplicate values, so these values this value will be duplicate, but we will keep first. Okay, so keep is set to be default value first, so we just will keep the first llama, and the second and the third duplicate llama will be removed. So the result is like this, and this will set keep equals to false, means that we want to delete all duplicate values. In place set to be true, so it means that the result series after removing the duplicates will replace to the original series. So if we call that, you will not return any object. You will return none. Okay. So and the original series S will be removed with the duplicate values. So we just Now all the llamas are deleted, and the S will contain the result series. So here we see here only cow, beetle, and hippo values are kept. Okay, the next related function is the reindex. So it means that we want to reindex the series, and especially that after executing this function, a new object is produced. Okay, it means the new series of the result, okay, is generated unless some parameters are set. Okay, so first step is that is the index, is the new index here. This is the new index you want to put in the new series. The next parameter is the method. Method means how you put or fill in the value into the new series. Because when you reindex the series, the index may contains some new index value. So it means that it will generate new element in the series. So the method define or indicate how to fill the value in the value for the new series. And copy means that if it will return a new object containing the result. Okay, the default is true, so that it means that the default will generate a new object containing the reindex series. So let's see the example. Here is the obj object. Obj here, the original series. Okay, they have index dbac, and the value starts from 0 to 3. Okay, you see here. And if we want to reindex, so you see here we have five index. It means that we will put a new element into the series. So here before A is 2, B is 1, and C is 3, D is 0. But E, the index E is a new index. But we do not assign the value for the index. So you see here, the value for the new index E is NaN. So it's not a number or not available. The next is the obj1 object, the series. Okay, it has 3 series ACE, and the value starts from 0 to 2. So you see here is the object 1 series. And if we call the index, we want to have a new index A, B, C, D, E. So it will have 2 new elements for object 1. And the method is pad. It means how to fill in the value of the new index. Pad means, so you see here, pad here. Pad here means it will propagate that's the value observation to the next value. So you see here, okay, ACE. Okay, ACE is the original index, and the value is here, 102. Okay, and B and D are new index, and the value should be NaN for B. But now we assign the method should be padded. So it means that how we fill in the new value for index B and D, then we will observe the last valid data. Okay, and we insert that data value for the new index. So here B should be NaN, but now we look back. Okay, we try to find the last non-NaN data. So that's A, and the value for index A is 0. So we fill the 0. We copy the 0 value for the new index B. Okay, and for D index, the value should be NaN, but now if we look back, the first valid or non-NaN index is C, and the value is E. Then we copy the value for index C to the value for index D. So this is the result. So it's a useful method if you don't want your series contains NaN or Na, and then you need to have a method or mechanism how to fill, how to replace the NaN value. Okay, and then here we set the method to be none. None means we will keep. Okay, we will not fill in the new value. We just keep the NaN value here. Here, we don't fill in the gaps for the new value. So the value for index B and D will be kept to be none NaN. Okay, not the number. Okay. Here we introduce a useful technique, how we remove the duplicate index in the series. So, for example, this is the series and the index here, and you can see uh, they are duplicate index here. Okay, and the values for the duplicate index are different. So it is possibly a noisy data, or even you can say error data. Okay, then we want to remove we want to remove the duplicate index. So we can choose which index and value should be kept in the series, and the others duplicate index and the values are removed. So we use index property to get the index of the series. So these are the index of the series. And here we use duplicate function to find the duplicate index. And we set the keep option to be first. So it means that the first duplicate index will be marked false, and the other duplicate index will be marked true. And also the non-duplicate index will be marked false. Okay, then we use the not operation. So the non-duplicate index and the value will be marked true, and the first duplicate index will be true, and all other duplicate index will be set to be false. And we use a slicing technique to get part of the series. And because we use the Boolean index as the index for the new series. So after the slicing of the series, only the mark true index are filtered out. Okay, so you see here. So you are trying to find the duplicate index. So we just keep the first one. So this will be, because it is the first. Okay, it is the first. Okay. So after this operation, the index will be marked as true. And also the index will be marked as true. And this is non-duplicate index, so it will be marked true. And this is the index value. Okay, this is the index value. So it means that we will take out. Okay, we will take out this value from the series, and we just re-index them. Okay, we just re-index them, and you see here here is the result. Okay, Here's the new result for the series. So this is a very useful technique, how we remove the duplicate index in the series.